Hello everyone, so today in this tutorial I will show you how to quickly run some SDR tools against the RTL-SDR using RF Swift. Because sometimes you want to generally play with a lot of tools like the Blade RF, the Hydra SDR, also Wi-Fi tools, some Proxmark, some VNA, some spectrum analyzer like this one, and also the RTL-SDR, some logic analyzer. And the issue that you may encounter is that you have to install a lot of drivers, a lot of tools. It's like hell. Sometimes you will also tend to use, for example, some distribution like Kali Linux, also like Dragon OS, for example, on RF. But sometimes you are stick with also with your own setup. You don't want to change the distribution. You don't want to change the setup. So if you want to run everything on, let's say, macOS, Windows, on Linux, but you own Linux, for example, and you don't want to change your current OS for that, and you don't have like an extra notebook, this is why you will use RF Swift. All right, so I have Debian installed in a VM, completely empty, and that's what I wanted to show, is that now I will actually use now a terminal like that, very simply. I would probably just like change the profile of the, at least the profile of this little terminal. Like that, we'll use GNOME Dark, and it will be better looking, right? Much more hacker, right? So yeah, I will also use sudo. So because sudo is provided by Debian by default, but I will probably just like use sudo for this user. So let me just use vsudo for that. Sbin vsudo like that, and let's go. Yeah, I'm using nano, so not the same as vim. I will just provide the user here. So like that, we just give some privileges to user like that. Perfect. And now I can use sudo. Perfect. So let's go now to RF Swift IO. The website of RF Swift. So you can take Firefox like that and go to RF Swift IO here. I will be able to install RF Swift. So there's like a lot of documentation about that. So if you want to know some specific mechanism or some specific features, everything is documented in RF Swift. The benefit of using RF Swift, as you can see, is that you can use it even in pretty everywhere. Like in every OS, a lot of architecture, a lot, like ARM64. You have also RISC-V 64. You have also x86 64. You can choose the OS and also the architecture. We use most of the common use architecture, except the RISC-V 64, because that one was just for fun, but also to prepare ourselves for some tools for RISC-V 64 after. But yeah, you can also use that on the Steam Deck, which is quite fun. And if we want to install it, there's a very, very easy quick installer here. So yeah, you can always install it manually following the doc, but for our case, we just want to to install it pretty quickly. So I would just like copy paste that. In Debian, we don't have curl. So you will have this error. You can still, for example, install curl like that, or you can also use directly wget. I can also show you with wget that you can directly also make it working. And by using the installer, you will see that there will be like some checks performed here. It also checks that this is there. If there's like some containers engine working used in the distribution, we see that we don't have like any container engine. So we have to begin with one. And the first one we will use, and this is the one that is maybe much more comfortable to use, is Docker generally, because Podman is also very good because, for security reason, you will use it because it's rootless by default. And generally, you have each container has its own rights, compared to Docker, where there's like a container D, which is demonized. So yeah, for security reasons, you will choose Podman. But for our first tutorial, let's use Docker. This is also the default one for many users. But for people who want to think about security, I will also do like some videos using Podman and also show you the difference between Docker and Podman as well. So let's use Docker. We'll install Docker and we'll wait a bit until it is finished. When it's finished, you can see that now Docker is installed and running. We also check the sound because sometimes also you want maybe the sound if you want to listen to some FM radio or use like some software that use the sound. You want to communicate also with the host sound card. Then it will download the binary. So yeah, don't hesitate to check the binary. The checksum shows you that, but I mean, it's preferred generally to directly also look at that file that you can click on it. You can look at the latest checksum and you can compare it like that. So yeah, the file that you should actually compare is this one. Always do that. I mean, it's some nice reflexes because I mean, we don't have like any min. I mean, some automatic secure min to check that. So you can check it by yourself and see we have exactly the same hash at the end like that. So that's perfect. So the thing that we have installed is good. We can now just install it. You can also choose if you want to have the binary system-wide or user local as, for example, here, we want, for example, in my case, I just create like a lot of users sometimes for testing and then I drop them. I like these users to have like the RF Swift installed. I will actually just use the system-wide. But if you want to just install RF Swift for your user particularly, you can also do that by typing no. And yeah, also system-wide installation for the installation of the binary requires sudo, and this one no. So that's why also it will ask you for sudo privileges. I mean for the script installation script. Also, you will see that there will be like some missing fonts. So it's not necessary, it's not required to work, but it is like much more stylish. So that means that if you want some nice prompts, you want to install it. If you want to just like some square prompts, not super beautiful, but I mean a prompt that works, you can also say no. I will say yes because I mean I want to show you also the nice prompt it will install. All right. Also, then it will ask you if you want to install Askinema. Askinema is a nice feature. I will show you that on other videos. So, for example, when you want to report something during a pen test and you want to record what happened, you can actually use Askinema, which is a very nice tool. So let's say yes, because it will be very helpful after. All right, so now let's also create an alias for RF Swift because we want to use it on the terminal at any moment. And then it is finished. So the installation script is pretty, I mean, awesome because it installs everything on the right place. If at any time, let's say you want to install things, you know, in an air-gapped installation, we also provide some documentation on how you can manage air-gapped installation instead. Here, don't be worried. Don't be worried about that. Let's now see how we can, I mean, we have AeroSwift that is working here. We can call it like that. And the first time you launch AeroSwift, it will ask you for profile. So you can choose no if you want. But if you choose no, you will have to use default profile that is provided by the binary, or you can provide them on yourself, by yourself using parameters. But then you will need to use a lot of parameters. So what I'm suggesting is generally to create one, and what it does, it will create something that is present here: config file, AirSwift config. So yeah, along these tutorials videos, you will see that I mean we have the repo tag, which is the default repository where we will be able to download images, and then we have some other parameters which actually tells the default value we should always use possible here. You can actually I mean, configure it as you want, for example, for C groups, so map device that you want inside the container. Also for bindings, for example, if you want to mount volumes automatically by default the display. And use extra host you want to define. For example, for Pluto SDR, I just define that the host name will be that, or that IP address, etc. I mean, this is something that you can configure it by yourself without any issue. And yeah, after that, if you want to, I mean, when it is already set up, you see that at the second run, I mean, it will not ask you that, but we need now some images. So if you go to the website, you will see that we have plenty of pre-built images. You can also build an image on your own. For example, if you want to have like your own repository, you can also specify a repository on the configuration file, but you can also build your own recipe. So if you want some specialized tools, some specific tools that exist on RF Swift, not take the whole image, you can build your own image here. And you can also use one of the image as a basic image. So yeah, if you want to know what kind of tool is installed, you can see, for example, the different image that we provide. So we have, for example, SDR build, SDR Lite, Bluetooth, hardware, telecom security tools here with 2G, 5G, 4G, etc. And yeah, as you can see, there's like a wall hierarchy. So that means that when you download, for example, SDR Lite, you download SDR SA layers also as well. So you don't have to download them again if you, for example, use the hardware image or Bluetooth image, for example. So only the remaining layers will be installed. So for our first try, we will actually download this one. And yeah, of course, it's better to check online what kind of image exists. So if you want to know what kind of image exists on the internet, you can write RF Swift image remote like that, and you can check up the existing image. So you can see Telecom 5G, Blade RF, Wi-Fi. I mean, and if you don't know what kind of tool is present, you can check up, for example, for each image, you can see the tools that actually exist for each image. You see, there's like plenty of tools that are already, pre-built and pre-installed. So like that, you don't have to do that by yourself, which is kind of cool. It's like having a Kali Linux, but without having the cumbersome Kali Linux at the end. So yeah, we can now just like go with image pool. So like that, what is cool is that I have a Debian for installation. I could have also Arch Linux or whatsoever. I don't need to change my distribution. I can just install the image and run the image and run the binaries, which is kind of cool. So let's say that I want to play with some SDR stuff. I can just like put SDR Lite like that. So I mean the first SDR image. If you use SDR full, it will install all the Auto3 module, all the tools around SDR, and would be kind of cumbersome. It's like a 40 gigabyte image at the end with SDR full. SDR Lite, it's lighter, much more lighter than that. It will just like run, some tools that are, used a lot. So you will see. But let's see now by downloading the image, how it works. I'm just pulling some image from the internet. All right, so when it is downloaded, you can use your image. So for example, here, just to show you, I can also see the local image that exists with the command image local. So you can see that the image is also up to date. I can also see the versions that I have installed. For example, here, you can see also the version 1.0.15 that is installed. Remotely, you can also do the same. And here also, if you want to, let's say, pull a specific image, an old image. So, for example, in some case, it can be also very good to have because sometimes some tools can be broken from one version to another. That can happen. And I will not say that it never happens. It happens. You can always go back to older image if you want. You can, for example, use image pull, for example, here as their lights and you can specify an older image like a 011 version here. Sorry, with dash upper cars V. As you can see, now we're downloading the image with this version instead. And so yeah, you will actually see all the image that will be installed here, as you can see. And then if you want to use the image, and this is now what we will actually do. I will just run, for example, the RTL-SDR. I will put that on the computer like that. And so when I just plug the RTL-SDR. When the RTL is plugged, I can run RF Swift like that. I will run it like that, and it will actually just this command will try to discover existing image. So this is a wizard. You can always use, some commands, some long commands, if you want. I will actually show what actually this wizard is actually doing. So let's just begin with the with that first. So we select the image here. We provide also a container name like mission one. So this container name is a container name that you will be able to use if you want to go back to this container. So every container is a sandbox. This sandbox is a box where you can do everything you want. You can even do a big mess and then you can remove it. And after you create a new sandbox, it recreates the same environment all over and over. So like that, you cannot break any tools. This is the advantage of using containers here, because if you are using, for example, an installation like a distribution that has like all the tools, at some point you will get used to use this one. You will install a lot of stuff, and at the end, after maybe a month or 2 months or even a year, a lot of things will be broken, and you will have to install everything at once, and it will take time to to install everything. So like that with sandboxes, all you need is like a fresh Debian, and then you can install directly all the tools you want. And what is cool is that you can create a container and you can export the container. You can save it to an image. So you can create also an image out of this container. So you can also scale your setup and you can install it everywhere you want. After you have provided the image, we have to also define the workspace. So workspace is a share of directory between the host and the container. So basically, as I'm using sudo, and Jenny, that's why also you need to use, Docker this way. So for example, you can use user mode here in order to just specify your user to have like the privilege to use Docker. Like that, it's better, and that way the workspace will appear in your user directory. But yeah, as I'm using sudo, it will actually use root as the user. So yeah, I would just like use a custom path. I would provide home, user. User is my actual user. I can provide like RF Swift workspace like that. And this is a space that will be shared between my host and my Docker container. So that means that if also I have like other containers that wants to share the same repository, I can do that. And like that, all the artifacts that I will generate will appear here. That's kind of cool. So yeah, you can also use extra volume binding. So extra volume bindings is a way to to have like orders shared between the host and the container. But in a case you want also to hot plug devices, because with a Docker container, if you map devices, this device will be mapped if they are present in the computer. But if they are not present in the computer, so that means that they are not plugged, it will be difficult to bring them, at least, if you don't stop and re-execute the same container. So you can always use dev bus USB, dev bus USB if you want. I will show that after that. But yeah, let's just keep our RTL-SDR inside the host and run the container normally. So like that, I will show you, the difference between, volume binding and default mapping. So yeah, you can also add some device mapping. Device mapping, what is actually device mapping? I can maybe show you that here. It's exactly the same file I showed you before. Like for example, in the configuration, I'm actually mapping dev bus USB. So that means that when the container is running, what will happen is that if the device are present in the USB port, they will be brought into the container. If you unplug them, they will disappear. And so you will have to stop the container and re-execute the container. It doesn't mean that you have to rerun, to recreate a new container. You just need to stop and re-execute. I will show you. But yeah, all the devices that will be mapped automatically by default will be these ones. But if you want to add extra device, you can. You can also export some ports. So that means that if you have like a web server, you can export. And that option is particularly interesting if you are using NAT network. if you want to export the port, you can export the port. But in our case, we will not export any port because we will use the host. But yeah, if you run NAT, if you run the container to a NAT network, NAT will actually create a new isolated network, and you can also define the IP address, the subnet that you want to use, and you will be able also to bring all the containers in the same NAT. So yeah, the export port can be actually relevant for this case, but yeah, for host, it's not relevant. But for bridge also, it could be also relevant. Now let's enable some features. So yeah, of course, in our case, we'll have like some features to use. So basically, if you want to run that by default, you can run that by default without any issue. But there's like some extra features that you can enable that could be fun, like the remote desktop. So that means that you can, with even a browser, you can also manage the container, and it will actually expose like a nice desktop mode thing. And yeah, of course, it will be in HTTP by default, but you can expose it in with TLS, SSL TLS. You can also disable X11 if you want. So like that, you have much less exposure also at this side. But yeah, of course, you will have VNC. But yeah, you can have like disable X11 and having remote desktop completely disable also as well. It's possible to do so. There's also the privilege mode. So if you don't want to care about the capabilities, you can also use privilege mode if you want. I will actually just first run the real-time mode, because the real-time mode can be actually very relevant for for stream IO. For example, if you want to stream in and out some samples out of the SDR, real-time mode will take care about boosting a bit the container in order to do that. You can also have a container connected to a VPN, which is cool because you don't have to expose the entire host. You just expose one specific container. So yeah, let's just run that as an example first, and then we'll do the following. You can also have like some extra capabilities. So yeah, if you didn't precise, for example, the privilege mode, you can select one or multiple capabilities you want. For example, if you want, for example, to set up like a tunnel, you would probably just like want to activate that. But yeah, you can also use other C groups that we provide. So if you need some specific C groups, you can also select them here. Now we are in a stage where we can create a container. So the command, the equivalent command that will be evolved is this one. So this is a command that you can also use in order to create a container and run it. But yeah, we have also wizard that take care about all of these things at our place. And yeah, now we have a terminal that changed. You see, it completely changed. At any time you can exit it, for example, using exit. And if you want, for example, to go back to this container, you can use exec. Don't need to use run. Just exec will be sufficient, because run will create a new container. Exec will actually just retrieve, a last container. So we will just retrieve this one, and now we can go back to this one. That's cool. Now let's maybe run some software. We'll use like SDRPP, for example, here. And then we can select SDRPP, RTL-SDR like that. And then when everything is fine, we can just like click on it and have the radio at some point. So you see, it's pretty nice. Also running like that in a VM, so it's not as fast, because yeah, we are using a VM here because I'm lazy also to install that on a bare metal computer directly, because I want to show also how Podman is doing, etc. So that's why also I'm running some VMs here like that. But yeah, I will also show you that on a bare metal computer like a Mac OS and so on, and also my own, like that you see also the difference. But yeah. Here you can see that we can run like some nice stuff. And you see the GUI is actually managed by RF Swift. Docker, you have like a lot of pain to do that with Docker. And with RF Swift, we do that pretty natively, which is kind of fun. And yeah, if by any case, and that can happen, if by any case I'm just taking for the RTL-SDR out of the container and I'm replugging it, you see what will happen. Look at that. here, yeah, just making sure that it will be inside. But yeah, when you do like SDR++, you will see that this device will not be present anymore. There's like no serial, so you cannot plug it, cannot do anything. So you need to stop the container. Do that without recreating the container. You have to do like stop mission 1 like that. You wait till it is stopped. That will completely shut down this container. So as you can see, also the containers can run in background, which is kind of cool also as well, and sometimes kind of tricky. You can use exec like that, or exec with the -c and mission. But yeah, exec like that will actually just like let you select also the mission 1 container, and then as we have stopped and rerun the container, we can go back here and we can use the RTL-SDR. You see, up now it has a serial number, which is kind of yeah. So it's pretty simple as it is. And if you want to make this change, I mean, if you want to make the USB permanent on the container, so you want to hot plug devices, there's a way. It's very simple. As I said before, I mean, there's like 2 ways. Actually, when you create a container, you can use the bindings. So you can use like bindings like that, bindings -c, add -c mission, and then you can add a volume like the dev bus USB, like that. So that will actually shut down the Docker container. That works precisely, beautifully with Docker, with Podman and so on. You have to recreate a new container. So it takes the, with Podman, it will actually recreate a new image extra and run then the container. Here with Docker, it's pretty straightforward. We need just to change the manifest. And then you see, I will be able to exec here. And I'm executing the container once again. And just to show you that I'm not cheating, up, I will just like take the RTL-SDR here. So you see, and then I can the antenna are falling. Up. Voila. And then we can go back here. And then you can do SDR plus plus. Plus plus like that. And you can see we can up. You can play with it. You have to click also on it. Yeah. So yeah, as I'm using that in the VM, it's not super quick, but yeah, it works well. Also, you have like RTL 43 if you want, for example. So that way, for example, there's like as you can see, some other tools where you can have like let's say some sensor that will be that you can probably just like see around like these ones. You can also have like for example URH that is already installed. So like that, you can also play with URH if you want. You can have like RTL-SDR. We have our own version of RTL-SDR, I mean of URH, so you can have ROGIC and also other device as well. So it's kind of cool. For some of the tools like jQuery, sometimes you will need also Pulse Audio running. So if you want that, you can have like for example, you can just enable Pulse Audio here as a TCP socket. So for example, we can do like without sudo, of course, because it does not need sudo. RF Swift host audio enable like that, and you will have a nice message telling you that now, PyPower, we have, a service run by PyPower. We can now go back to jQuery and have a jQuery showing. And yeah, now it's better. And as I said, it's like a sandbox. So if you mess inside the sandbox, it doesn't matter. So let's say that, for example, you just mess up with SDR++ and also libraries and so on. So this is the particular case where this can be very helpful compared to distributions. You can have like that, for example, that disappear. So you cannot launch SDRPP anymore. So if you want to launch SDRPP, you can just create a new mission. So you can do like up, mission 2, same parameters as before. I can just like disable the workspace. I can make the same workspace. Wait a second. Up, user, workspace. So work, RF Swift, workspace like that. Yeah, I'll just do like that's by default like that. Up, capabilities no, create a container. All right. And then I can just, I mean, I can just relaunch SDR++ like that. Up and reselect RTL-SDR. And once I want to remove some stuff, I can just like, if you want to, let's say, delete some VMs, you can also remove like that. You can also precise which one you want to remove. Let's say mission 1. Let's remove mission 1 and it's removed. So like that, you can also save space and you have only a mission 2, which is exists. There's also like a nuclear option, like a cleanup containers that exist. So if you have like too much containers and you want to clear like, to remove all the containers, boom, you can remove all the containers or all the images. You can save space at the end. Another cool thing that you have also with RF Swift, because if you think that's, it's life is too short and you want to create, containers much more quicker than that, you can also create some profiles. And profiles, for example, I have made like a profile for SDR default. I will also show in some videos that you can, use this profile. And so you can just use it as it is, and you can just, provide the container name like super mission like that. You can create the container and it will just generate the container like that. All right, so now you know how to run the device, any device like Blade RF, an SA, whatsoever with RF Swift. So you can look at the tools that exist for each image. And I think that you will actually find some nice image that will actually fit your expectation. You can also create your own image. But the thing is that it should actually run pretty everywhere. Like it can run on any Linux, it can run on even macOS and Windows. So, and on some other architecture than just x86 64. So yeah, it should be like ARM 64, RISC-V 64. So yeah, plenty of architectures. And that's it for this video. As you can see, RF Swift is very nice to run any device. In pretty everywhere. Like you can run it on Debian, Ubuntu, also Arch Linux. You can also run it even on the macOS. I will show you also Windows. Plenty of things. So it's super powerful. And I'm making this video because, of course, there's like a little learning curve compared to using just like directly a distribution. But at the end, I think that for work case, and this is actually my case, sometimes I have like a laptop, a clean laptop because I don't want to bring all the tools during missions, and I need to install things pretty fast. So as you can see, in like 4 minutes, even 10 minutes with very big image, I can have all the setups I need. And what is also interesting is that you can create your own recipes of image. So you can create your own image, have your own repo, and so everything is ready. You can scale up. So thank you very much for watching and see you in other tutorials.